Okay, good evening, students.
Good evening.
Good evening.
Good
Okay,
evening.
I am Professor Waluchwati, and I'm going to take you through mobile programming, or what other people say, Android programming. So, kindly allow me to share my screen so that we can know and see what is going on. Okay, by the end of this lesson, you should be able to identify at least 5 key components of the Android architecture. And you should also be able to explain the role of each component uh, in mobile application development with one example in each and every layer that we are going to, to look at. So allow me to move on. So we are going to start by defining what is mobile programming. So anyone with a clue on the definition of mobile programming? Have you ever heard it? Anyone? Okay, yes, I can see Kevin is raising his hand.
Let me
Let
try.
me try.
Okay.
It is
The
the
creation of
creation
apps.
of apps.
Okay, that's good. So mobile programming is just the process of creating applications which can run on smartphones. Just creating applications that can run on smartphones. As you know, a smartphone uses an operating system which we call Android, or even iOS, or other mobile platforms like those on Nokia and Microsoft devices. So mobile programming involves writing code, designing user interfaces that we usually call UI, testing and publishing. Testing and publishing. So you can publish the app on Google Play Store and other platforms. So developers use tools like Android Studio or Xcode to build and test applications. So common languages that are used in developing mobile applications, we have Java, then we have Kotlin for Android and Swift for iOS. So recently we are mostly using Kotlin and Swift because like for Android devices, uh, Google just moved on to Kotlin and they shifted from Java. So we are no longer using Java, but we are using Kotlin and Jetpack Compose. So, okay, we want now to look at an emulator. So, what is an emulator? An emulator is just a device that simulates a mobile. It is just like simulating a mobile device on a computer. Are we together? You simulate like you copy or emulate features of a mobile device on a computer. So it is used for testing applications without physical hardware. You don't necessarily need a smartphone connected to your computer to use emulator. Emulator is just like copying Android devices. So it supports Android versions, sensors, and network conditions. Uh, it also helps in building into Android Studios as AVD, or Android Virtual Device. We want now to look at the life cycle of an Android application. So with Android applications, we first start by uh, uh, initializing something we are calling on create. So if you give that instruction, the app will be initialized. Then on start, that is also a code or a line, a statement that makes the app to become visible. Then on resume, the app is active and interactive. Then on pause, the app loses focus, or it is like it has stopped functioning a little bit, but it's not off. Then on stop, the app is hidden. Then on destroy, the app is terminated. So that is the life cycle of an Android device. Kindly note this somewhere because it is very important. These are the very important cycle steps you should know. Are we together?
Yes.
Then we are moving
Yes.
on. So we want now to look at the Android architecture. So the Android architecture is structured in different layers. So there are layers that are near the software and the other layers near to the hardware. So we want to start by the most outer layer, which we are calling the Linux kernel layer. So this is the base of the Android. It handles memory, processes, security, and hardware drivers. So then the next layer, we have the hardware abstraction layer. You can also shorten it by HAL. So this one bridges hardware and software, or it standardizes access to device components. So it is in between there, between hardware and software. So it acts as a bridge or a ladder where the apps can communicate are we together. The app and the device will be able to communicate well. Then Android runtime, you can say ART, Android runtime. So this is layer number 3. It executes the app code and it also manages memory, threads, and garbage collection. Then we have the next layer, which is native libraries. We have these are the C or C++ libraries like SQLite, OpenGL, WebKit, Boost, performance for media and graphics. So then the next layer is the application framework. So the application framework here just provides APIs for user interfaces, activities, resources, and system devices. So the next layer we have an application layer. So this is user and system apps. Now the apps that we develop, so they fall under the application layer. They are installed here, so they interact with the framework to deliver functionality. So any question before we continue? Someone maybe has a burning issue or any question? There being no question, then we are going to continue with our session. So the key concepts that we should know are as follows. So mobile applications must manage resources efficiently. So when you're designing the mobile applications, we should ensure that they manage resources efficiently so they don't waste memory, they don't waste storage, etc. Then life cycle methods helps control app behavior. The life cycle that we just looked at in the recent slide just help to control the behavior of the application. Then the emulator helps to test across devices and conditions. The emulator helps to test across devices and conditions. Now, we want to look at the recap points or points to remember. So an emulator, we said it's a virtual device for testing Android applications. So you just test on the computer. We don't connect a device. Then the app life cycle, these are just stages for creation to destruction of the app that we have in question. Then the key methods or the key life cycle stages we looked at on create, whereby the app was created, and then on start the app started running and active. On resume the app was active, then on pause the app just went on hold, then on stop the app stopped running, then on destroy the app is terminated. Are we together?
Yes.
Yes.
uh Having learned all that, we have reached the end of our session today. And kindly ensure that you you mark the attendance. I remember I gave the class rep the attendance, so make sure you mark as I will require that during our next face-to-face session. So thank you for having taken your time to come to class, and you guys just have a nice evening. Thank you.